Let r of x equal x times the quantity x minus 4 times the quantity x plus 2 in the numerator and x squared plus 5x plus 6 in the denominator. State all wholes and vertical asymptotes. I guess we're not worrying about zeros. Oh, I see why. I don't know why there's an Oxford comma there. I'm not going to complain. I'll just blame the person who made this problem. So in order for us to do that, I need to make sure both the numerator and the denominator are completely factored. So the top part is good, x times x minus 4 times x plus 2, all over, factoring u is two numbers that add up to 5, multiply out to 6, are x plus 2 and x plus 3. Now there's 5 factors, which means there's 5 magic numbers, and the magic numbers are the numbers that make each factor equal to 0. For example, plugging in 0 makes x 0, and that makes the whole thing up here 0, and all that fun stuff. Plugging in 4 makes this factor 0, plugging in negative 2 makes that factor 0, plugging in, negative 2 makes that factor 0, and plugging in negative 3 makes that factor 0. Now, I'm going to label all of these what I know that they are. Okay, get it out of the way, even though I'm going to accidentally answer B a little bit, no big deal. Anything that has just a factor in the numerator and nothing like it in the denominator is going to be a 0. So 0 is a 0 and 4 is a 0. Now, anything that is in the numerator and the denominator the same amount of times is going to be a whole. So negative 2 is a whole and negative 2 is a whole. Anything that's in the denominator all alone is going to be a vertical asymptote, so negative 3 is a vertical asymptote. Now when we throw multiplicity in here, that changes the game slightly, and you have to worry about which one's more dominant, the top or the bottom or whatever, but it seems like we don't have to worry about multiplicity, not at all. All right, so in order to answer A, state all wholes. Well, my wholes are going to exist at x equals negative 2, so just one of them. So whole is x equals negative 2. And my vertical asymptote is going to live, asymptote, is going to live at x equals negative 3. Now, x-intercepts, you might be thinking, what the heck is that? X-intercepts is just a fancy word for 0. So just, changing the words up a little bit. X-intercept is going to exist at where was it? 0 and 4. So x equals 0 and x equals 4. Now, how do I figure out the y-intercept? Well, the y-intercept is found by by taking the constant upstairs. So let's say it's 5, and the constant downstairs, and let's say it's 3, and just simplifying that. Well, here's an issue with this. If we look at the problem that we have, okay, if we were to look at all the factors, technically this could be written out as x minus 0. So if I were to multiply all the numbers up here, all the numbers up here, all the numbers up here, I would get 0 times negative 4 times 2, which is 0. Okay, and so down on the bottom here where I have 6, I would get 0 divided by 6, which means 0 is going to be my y-intercept. Now, why would this make sense? Let me write that out and tell you in a minute. If the x-intercept is 0, that means whatever this picture looks like is going to go through the origin, which means of course the y-intercept is going to be 0. Everything makes sense. Now, this last one's not going to be that much fun, although I purely enjoy it. Okay, my job is to find the equation for the slant asymptote. The slant asymptote exists when the numerator is 1 degree higher than the denominator, and then we do polynomial long division. In order for us to do that, though, I need to completely FOIL this guy out. So I have x times x minus 4 times x plus 2. So let's do x times that guy. X squared minus 4x times the quantity x plus 2. Let's FOIL this out again. X cubed plus 2x squared minus 4x squared minus 8x. And then combining these two, you get x cubed minus 2x squared minus 8x. Now what I'm going to do, since we're going to do polynomial long division, is I'm going to attach a plus 0 at the end because it makes it look pretty. So let's set this guy up. All right, underneath the division symbol, we have x cubed minus 2x squared minus 8x plus 0. Underneath here, we have x squared plus 5x plus 6, and then we do a little bit of polynomial long division. X squared times what is x cubed? X squared times x is x cubed. So you take that x, multiply it to this whole factor down here. X times x squared is x cubed. You will always get the same thing here, otherwise you did it wrong. X times 5x is positive 5x squared. X times 6 is positive 6x. Now you subtract that entire row, which means you flip the signs. So u will go away. Negative 2x squared minus 5x squared is negative 7x squared. Negative 8x minus 6x is negative 14x. Drop down to plus 0. And we do it again. X squared times what is negative 7x squared? Negative 7. Now here, I can stop. And if you're like, whoa, 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 whoa. Why? We're not done the problem. I know we're not done this problem. But what I need to do is, in order to find the slant asymptote, you are trying to find what happens before the remainder. I don't care about the remainder. All I know is I'm going to get a linear equation y equals x minus 7. Doing the rest of this problem would serve one purpose and one purpose only, to find the remainder, and I don't need that. So the slant asymptote is going to be the linear equation y equals x minus 7. Okay, so we can stop right there. All right, so this kind of gives us a little snapshot of what this looks like. We know that we have a slant asymptote of x minus 7. We know we have x-intercepts and y-intercepts and holes and vertical asymptotes, and we can draw ourselves a general picture of what this guy will look like. Not that we had to, but we have a good idea as to what this guy will look like. All right, so that is the third free response question. One more to go.